Welcome back to another episode of Heavy Wireless Podcast. My name is Keith Parsons, and today we're talking about MDUs, multi-dwelling units, places where people live really, really close together. Personally, I started in this industry about 20 years ago when I was called to go to multiple countries around the world to put in this new Wi-Fi thing where people are dense together. It seemed like a nice solution where you could bring Wi-Fi to lots of apartments or units at the same time. But the business model was a little flawed then because the technology and what they wanted to do at a cost point was difficult. A lot of people did outside in, where you'd put an access point on the side of one building pointing at another building, trying to punch through the exterior wall to get to the client devices on the inside. We've come a long way since then, and now we're on the inside out, where most MDUs are now putting one device per unit or maybe one device every other unit. On today's episode, I've got a couple of experts in this field. One's named Kyle Leisner, and he's the founder of WireStar, a provider of Wi-Fi for MDUs, along with Bart Giordano, who's president of the RUCKUS and Networking division within CommScope. To get started, Kyle, can you tell us a little history about how you personally got started in the MDU space?
Sure. Well, I started a dial-up ISP when I was in high school and wasn't focusing on MDU at that time, but I quickly went to college at Texas A&M University and started out living in, an off-campus student housing MDU type complex. And when I was living in that complex, I started, understanding the internet that was there and what was available at the time, and decided I wanted to improve that experience for college students. I then got my master's at Texas A&M University, and through that process, I was able to then form WireStar to service that market.
Okay, you don't look old enough to have run a bulletin board system. You said dial-up? Wow. Did you start when you were 10 or something?
No, not quite that young, but I was a junior in high school, so really liked the internet at the time and honestly wanted to find something to sell. So I said, why not sell the internet itself? So I went to a wholesale dial-up aggregator that provided phone numbers to AOL and Earthlink and other large dial-up companies, formed a radius system to allow people to gain instant access by putting their credit card into an online billing subscription platform, and then handled every aspect of that business, whether it was doing customer support and care, troubleshooting and programming. So quite a bit was involved, and some of those lessons that I learned forming that company, I still take with me today at WireStar.
You people out there who actually used radius as dial-up in that dial-in service, I'm impressed. So what are the unique things that are going on inside of a multi-unit dwelling, an MDU, that bringing Wi-Fi to that area a difficult challenge?
Well, first, multi-dwelling units are very dense. There's a lot of units in a single building, and so we have a high amount of dense AP deployments. And then in addition, most of the properties that we service are student housing or conventional, and both of those have a high demand for users that want the latest gadgets installed on their networks. And so these networks are a guest network on an enterprise network with a residential type experience. So it's a unique situation there in those complexes.
So how did you go about solving that unique problem?
Well, first, we brought RUCKUS into our ecosystem. RUCKUS had some very unique features to service multifamily units, namely their DPSK technology. That allows us to operate the network as an enterprise-grade network with the security that we need to be able to allow devices onboarding to the network in a residential setting. A lot of enterprise-grade networks are deployed with 802.1x or other authentication mechanisms that cannot be used in a residential setting. So the DPSK solution was really key for us with RUCKUS.
So can you describe for our listeners what is DPSK? Is that a RUCKUS-specific thing or is it a generic term?
It is a RUCKUS-specific technology. This technology allows you to have one single SSID, but multiple different pre-shared keys. Each pre-shared key puts a user in their own unique VLAN and segregates the network.
You just use some terms, segregate network, VLAN. In an apartment unit, how do you explain that to the residents? I'm sure you don't use those terms. They don't quite get that.
Indeed. They definitely don't get those terms, so we explain it to the residents as they get their own unique password, just as they would if they lived in a single family home. And that password allows their devices and only their devices to access that network securely.
And is Ruckus the only solution that provides that?
It is a Ruckus solution. Others in the industry have tried to copy said solution, but it's not quite as advanced as what Ruckus offers today.
Okay, so if you're into one of these MDUs, how do you deal with the RF in that super dense environment? Do you own all of the radios that are in a building, or do you allow individuals to have their own? What's kind of the RF environment you're working with?
The RF environment is usually very noisy when we first go into a multifamily apartment complex or student housing community. That's because a lot of those residents have their own access points or routers from the existing service provider. We go in and first remove all those access points and routers. Most of the communities that we service are bulk, meaning that we provide coverage to 100% of the building and usually include it in the rent. So our situation, because it's bulk, we deploy an access point typically per unit. It depends, of course, on the unit size. Some smaller units, smaller in square footage, we're able to get by with an AP in every other unit. But our traditional deployment model has an AP per unit. And then we have to do advanced channel planning. We use tools like EQHOW and others to define the channel plan and do predictive analysis. And then we use tools from Ruckus, namely Ruckus AI, to be able to analyze that channel plan once deployed and then make adjustments on the fly.
Bart, you're in on the conversation. What other things is Ruckus good at in this space other than the DPSK and the Ruckus AI?
Well, I think, the expectations of a resident that are living in an apartment complex or student accommodations or even assisted living facilities, military barracks and the like are very different than what you find in an enterprise network. And so, from a Ruckus perspective, we try to think deeply through the uniqueness of each industry that we serve and solve challenges that are faced in that industry to drive a specific business outcome. And in the case of MDU, that business outcome, the value proposition to the resident is a fantastic and secure experience with property-wide coverage, whether you're in the fitness center, whether you're in your apartment, when you're in other common areas. And so being able to deploy a property-wide SSAD, but with that personal area networking experience that Kyle mentioned is something that we do uniquely. And then driving operational efficiency at the property level is another capability that this solution brings. So it's not just value to the resident, but it's also value to the property owner. Property owners are not concerned necessarily about the underlying technology, but when we pitch them a value proposition, it's about net operating income and asset value. And these networks improve both. And when you layer in IoT technologies and the capabilities we have for connected entry, staff safety and security, energy management, et cetera, we bring a value to the entire value chain in the MDU environment, the residents and the property owners and the property management groups.
Well said, Bart. You sound like you work for a company or something. As just to back that up, Kyle, have you found that same experience in dealing with your property owners?
We definitely have found that same experience in dealing with our property owners. At the end of the day, they are our actual clientele in most situations. They're the ones that we're providing that Ruckus system to. And they really love the ability that not only do we provide a network for their residents, but we also provide it for their IoT systems, their corporate networks. And there's quite a few of those networks at a traditional apartment. You're going to have the access control system, video camera systems, locker systems for packages, and a whole host of other network-wide systems that have to communicate, whether that be in the leasing building or office or anywhere on property. I mean, these systems are all over these properties, and some of the properties we serve are over 1,000 units. So with that being said, I mean, these are miniature towns in some sense that we're providing this access to.
What technical difficulties have you had coming into a site like that? That density makes RF very difficult. Have you gone about solving the density issue of that? There's a lot of RF in the same space.
We've had to really do the channel analysis and power analysis of how much we're outputting at each of these properties and each individual unit, and really measure that using, client statistics from the actual devices that connect to the RUCKUS controller, as well as looking at the actual analytics and seeing how well the clients are actually connecting. RUCKUS AI gives us a really cool insight into this. And for example, we can implement a new change. So if we can say, hey, a certain AP, we need more RF output power. We can then change that RF level, and then we can look at the before and after of how the clients adapt it based on that using the RUCKUS AI. So it really gives us that before and after analysis to be able to say, hey, this change that we decided to implement, was it positive or negative before and after the change?
Bart, can you explain to us, if you can, the technical side of that AI decision? What goes into that feedback that Kyle just mentioned?
Yeah, certainly. So I think the process that Kyle just described around channel planning and mitigating co-channel interference is about to become infinitely more complex, as I think we all appreciate, right? In jurisdictions where 6 gigahertz is now available, we've added 1,200 megahertz of new spectrum, 59 new non-overlapping channels. You have 5 different channel bandwidths to deal with, and you're trying to figure out what your power control is across all of those. So it's a perfect problem to point at AI. And with RUCKUS AI, we're able to continuously analyze co-channel interference and automate the process of eliminating co-channel interference in the network by doing the analysis that Kyle mentioned, which has historically been largely a paper exercise or using off-the-shelf tools. The network itself can now automate that process and entirely eliminate interference in even a very complex, very dense environment. And we're using a variety of different tools and algorithms to accomplish that, particularly with the AI-driven radio resource management. We use a technology called Graph AI. This is what Google, for example, powers their search engines with. And so we have a suite of algorithms and tools at our disposal now that, given cloud scale architectures, we're able to deploy across all of these networks and continuously learn and evolve on an hourly basis to ensure that we're eliminating interference and maximizing the user experience.
What's the input into that AI algorithm from the client standpoint? A lot of vendors use AP to AP communications. They might go off channel and scan. One of the things the AI can bring is how do you know if it was a positive change or a negative change without a feedback loop? So what's that feedback loop that you're using?
So we have client information coming in, through the APs. We also have the APs themselves that can behave as clients. And so we can proxy for a client behavior using one of the APs. The APs are understanding how they see each other and trying to mitigate, the interference on a common channel, et cetera. And we have a suite of KPIs that are constantly being tracked and monitored. We store, in some cases, up to 1 year of data in the RUCKUS AI platform. And so, as Kyle mentioned, pre and post a configuration change, we can look at the impact on those APIs. You're also able, with RUCKUS AI, to do config change analysis prior to actually making the change. So we're able to assess, what the impact of a potential change will be. And then, as Kyle mentioned, once you make it, you're able to analyze the key performance indicators that would indicate whether the change was successful. And then you can automatically and retroactively go back to the previous configuration if as necessary.
Is there a human inside that loop?
Not particularly. The way we thought about designing RUCKUS AI was we want to replicate the process and workflows that an engineer traditionally went through when doing this manually, right? Prior to the availability of data science, machine learning, and AI applied to these problems. So initially, there was a lot of interviewing of engineers that do this on a daily basis to try to replicate their processes. But now it's entirely automated with the cloud. And I think, the human intervention comes when you're analyzing the KPIs, et cetera. But for things like anomaly detection and a recommendation engine to help you remediate those anomalies and improve your mean time to resolution, there's very little human involvement in those workflows.
Kyle, you'd mentioned you run this every hour. I mean, you don't personally run it every hour, but it's in the background making those changes?
Yes, it's in the background, and it's extremely easy to implement and turn on. Just going back to what Bart said about, how much human interaction is there. You turn on the feature, it analyzes and gathers that data. It takes about 2 to 3 days to get enough data to actually do the RRM aspect of this. And then it makes a recommendation, and it shows you before and after. And it's really neat in the sense it draws almost what looks like a spider web, and it shows all the APs and how they're laid out. And then it displays every single channel between them and what links are inhibited. And then it makes a recommendation. It says, if you lay out this channel plan based on what the AI has determined, we will get rid of X amount of links that are inhibiting or basically overlapping each other. So it's really neat technology. And then not only that, it's just really easy to actually implement, because once it does that analysis, it then puts it on the screen. It says, when would you like to schedule this config change to happen? And so you can schedule that, after hours or right then and there if you want. And then you can see that before and after analysis. So it's really, really easy to implement. And that's what we really like about the product. We've seen other vendors in this space that have AI, of course, but it recommends what to do, but it doesn't actually push that change or actually do that. It still requires a human to go in and individually put overrides on APs and say, put this one on this channel and this one on this channel. And that's still a very manual process. So we really like the RUCKUS AI aspect, where it does before and after and actually pushes the change to the controller if we allow it to do so.
And it enables us to handle a tremendous amount of complexity, because this RUCKUS AI RRM algorithm will work in three-dimensional space. I think a lot of times channel planning is done on 2D floor plans. And obviously, in this case, and in many cases, you have high-rise buildings or other multi-level structures. And you can see interference, vertically as much as you can horizontally. And so that just makes it infinitely more complex problem to try to solve. But again, data science and AI are perfectly adapted to that kind of situation.
Good. Well, I'd like to go back, if we could, Kyle, could you walk us through what a end user, a student who's, checking in for the first time, it's their freshman year, they show up at the apartment complex, how do they get from that first interview until they're, in their room, on their laptop, picking their schedule?
Yeah, definitely. So when a student typically walks into their, unit for the first time, they have a leasing packet they usually get from the management company. It gives them all sorts of details on, of course, how to, pick up their trash and get to all the services and amenities that leasing company provides. And one of those things is, how do you access your internet? And it's different property by property, but our typical is we have an open network where they're allowed to register. It's as easy as them putting in their credentials, their first name, last name, email, phone number. We then authenticate them based on that data, usually integrate it with the property management system at the property or by secure access codes. And then they instantly get their PSK or password to be able to get on their network right then and there. So it's an instant on experience. There is no technician to come out to the property. There is nobody to call at WireStar that they have to wait on. They instantly get access to their network. That key is then shared with them on the screen as well as by text message and email. They can then add all of their devices just as they could at their single family home that they moved from, or another apartment for that matter. So, it's a very easy experience for them. They don't have to wait on anyone, and it's instant on. The second they get onto the network, they're able to roam property wide. So they can be in their unit, and then they can go out to their car and go through the parking garage and still stay connected. And that's really important, especially with Wi-Fi calling, because if you're on a Wi-Fi call and you leave your unit and you're going through those hallways, a lot of these properties are high rises or even garden style, and they're dense. There's a lot of concrete, there's a lot of metal in a lot of these buildings, and traditional cell phone service does not work well. So Wi-Fi calling is another big aspect that this system achieves.
On the Wi-Fi calling, one of the things I did in researching for this talk was I found some RUCKUS white papers and best practice guides, one on Wi-Fi calling. Kyle, what did you have to do to enable Wi-Fi calling to be as smooth as you just described?
Well, first, you do have to define the different profiles for each of the cellular carriers, and RUCKUS does have a best practice guide on how to do so to establish connections with AT&T and T-Mobile and Verizon for that matter. Some of those carriers, support Wi-Fi calling better than others do, so that's really just property and location dependent. But you define those profiles and then enable that on the WLAN template, and then it pushes it out to all APs of the property. And what that feature does and why it's unique compared to some other Wi-Fi vendors in the market space, I think anyone will claim, hey, my access point supports Wi-Fi calling, and I'll agree with that statement for the most part. But RUCKUS has a unique aspect where they actually ensure that cellular handoff coming into the property. So say you're in your car, you're still on the phone, you get out of your car, and then you walk into the property still on that phone call. They have the ability for that phone call to jump from the cellular tower onto the Wi-Fi network and still have that same call happen. And then leaving the property, the same thing happens. It transitions that call from the Wi-Fi calling to the cellular network, and that's achieved through that proxy mechanism.
Okay, Bart, explain the secret sauce there.
Well, I think it's understanding the nature of the traffic and signaling across a mobile network and a traditional enterprise network, and then prioritizing that traffic accordingly. So, being able to detect voice traffic, put it into the proper WMM queues, and then being able to facilitate that handoff because you understand what the carrier server is, and you understand the appropriate signaling and signal levels when you're, getting further away from an AP or closer to an AP, and how to trigger that handoff with each individual carrier. And so there's a lot of work that goes into it. It's not a traditional use case for a quote unquote enterprise network like you'd find in an office space. And so again, it goes back to thinking through what are the unique use cases you're going to find in a residential environment where you're applying these enterprise principles, because Wi-Fi calling and that experience around seamless roaming for students is absolutely critical.
I think I might disagree with you a bit there. There's a lot of enterprises who need better Wi-Fi calling.
Yeah, certainly.
Because cell towers don't go everywhere they need to. Yeah. And I think the carriers have figured out they can save money. They don't have to put in the DAS systems they used to do by just saying, go ahead, put it on Wi-Fi.
Absolutely.
Kyle, if you were going to do this over again and put yourself back, 15 years, whenever you got started, what would you do differently?
If I had to go back in time and do things differently, I think we would have got started more in the bulk environment from the get-go. We came from a carrier heritage where we were installing, units one by one. So someone would call us to sign up for service, and we would have to then send a technician out to that apartment complex and install their modem in a traditional retail environment. And we quickly learned, especially here in College Station, Texas, home to Texas A&M University, that has the largest student population in the United States, that was not a very good business model from, installing a single family home for 9 months, all to then have that student move out or that resident move out of that apartment complex. So there was a lot of truck rolls involved. And looking back, I wish we would have got involved in the bulk side of it quicker, because it's just great to be able to install that system from the very beginning and have that instant on experience. And it was extremely helpful during COVID times, of course, because residents didn't want anyone in their unit. There was no visitors allowed. So having that instant on experience where when someone moved in and we didn't have to actually dispatch anyone was a phenomenal thing for COVID.
What's your percentage breakdown of retail versus bulk today?
Today, it's on the bulk side, it's over 80%. We still have about 20% retail customers, and that's changing. There's a lot of regulation going on right now with FCC that I won't get into, analyzing bulk contracts, and we're uniquely, situated there where we were in the retail space, then went to bulk, and now, it might be a combination of both those business models going forward. So I prefer bulk, and I think it's better for both the resident and the property owner and the service provider. The resident gets a high quality enterprise grade experience, and then the service provider, we are able to service the entire property and do so at a lower cost that then gets passed off to the resident and the property owner or developer.
Do the property owners like the bulk themselves? Is it better for their own? I mean, they're all about making money. That's their business. How does having a bulk system that provides Wi-Fi internet access help with the owner?
Well, because we're providing bulk service to 100% of the units, we are able to then offer significant savings to the property developer, and then they are able to put a slight markup on that service and provide it to the residents, and they're able to provide it to the residents at a lower cost than they would get from a traditional provider that's offering just individual retail rates to nearby homes in that market.
Bart, you had mentioned Ruckus likes to focus on helping individual verticals. What other verticals is Ruckus? We talked about MDU, but I'll give you a chance here to. What else is Ruckus really good for?
Yeah, sure. So any vertical where a premium connectivity experience drives a business outcome is perfect fit for Ruckus. We've talked about some of those business outcomes here when it comes to MDU. We also have a big focus on hospitality. Similar deployment model to MDU, the difference being a short-term versus long-term rental. But I think we all appreciate if you go to a hotel and you have a poor connectivity experience, whether it's on cellular or Wi-Fi, you and your children and family are not going to go back and stay at that property again, right? So that's not a successful business outcome. Very similar in education, both primary and higher ed. Educational institutions are transforming digitally, and a solid networking experience is paramount to drive the business outcome of digital transformation in education. And we're expanding now to other areas like manufacturing, warehousing, and logistics. With Industry 4.0, you have factory automation and other use cases where there's many more things coming on the network, not just users and their devices. And a premium connectivity experience can prove the operational efficiency of a warehouse, a distribution center, or a manufacturing environment. So for us, it's all about premium connectivity. And again, thinking deeply through the use cases and business outcomes that these organizations are trying to drive, and then working backwards to evolve our product portfolio to achieve that outcome.
Well, I'd like to thank my guests today, Bart and Kyle, talking about MDUs. You've been listening to another episode of Heavy Wireless Podcast, part of the Packet Pushers Podcast Network, and we look forward to talking with you in the future.